right, so it's time now to move on to tangent functions. We dealt with sine function and cosine functions, and now we're going to deal with tangent functions. So tangent functions, I want to start with the unit circle again. If I have this standard angle theta that is being created right there, with the given a coordinate xy, remember that xy were basically cos theta and sine theta. Okay, so this part right here, the vertical piece, that is the sine theta. This is sine theta, which is y value, and the x is the cos of theta, which is x value, because the radius is 1, right? So the radius, the hypotenuse of this triangle is 1, where the standard position is being created. All right, so based on that, you notice that tangent is opposite over adjacent, and therefore tangent of theta is sine theta over cos theta. Okay, and this is actually a rational expression. And if you remember from the rational function unit, either in grade 11 or the previous sections in this grade, in this level of math, notice that the denominator cannot be 0, because the rational expression or reciprocal expressions or functions, they will be undefined if you have a denominator of 0. That means cos of theta, the denominator cannot be 0. And what are the values, or what are the values of theta, the angles that make cos of theta equal to 0? And whatever those values are, we need to eliminate them, or we need to discount them, and those values are pi over 2 and 3 pi over 2. Now if you are in doubt of this, you can go ahead and graph y equals to cos of theta, the function cos of theta, and look at their x-intercept. And the x-intercepts are those two, between 0 and 2 pi. So we cannot have those. All right? So, and because of this, what you will have, you will end up getting what we call, again, if you remember, asymptotes. Okay, that's what's going to happen. So we're going to go ahead and graph tangent of theta, and we're going to use the interval between negative pi over 2 to 3 pi over 2 in between, and we're going to use a table of values. Okay, so we're going to use Desmos to help us out. So here are the table of values, and you can use your calculator. Basically, you come up with any random numbers anywhere between as high as you can start with. Now we started here as -2, but it could have easily started -100. Plug it in there, and it is in radians. Make sure your calculators are in radians mode. I did not use a degree mode. This is a different unit, radians we are using, so you got to stay on radians when your calculator. It's very important. And once you plug in the numbers in the calculator, you will get these values come out, and sure enough, you will see this type of a graph. It does not look like a sine and cosine graph, but what it looks like, I want to zoom in. I want you to see what is happening. Okay, so remember that minus pi over 2 and pi over 2 and 3 pi over 2 were the asymptotes. These were the non-permissible values. So the graph is very much asymptotic, just like a typical rational function. And the vertical asymptotes, there are numerous vertical asymptotes with the tangent function, just because of its periodic. So it repeats itself every period of this function. Now every period, and you can see this graph is repeating itself every pi interval. Okay, so from minus pi over 2 to pi over 2, you see that? That's the full cycle, and then it repeats itself again and again and again, and it goes on and on and on. And I put in there one value just to kind of get your attention. 99 pi over 200 is very, very close to pi over 2. And I wanted to make sure that you see that the value of tangent of that value, it gets really, really big, 63. And this is not even that close to pi over 2. I can even come to 1,000th of a decimal close to pi over 2, and the value of tangent of x will be in the thousands. So if I zoom out, you notice that here is the point right up here where that's the point of 63.65, and it continue going up the graph, because it's becoming asymptotic and close to pi over 2 without really touching the pi over 2, or in this case 3 pi over 2, and of course all of the other repeated asymptotes. Okay, so period is that, does it have amplitude? No, it doesn't make sense, and we're going to talk about that, because we can't call it an amplitude. It's just a vertical stretch, but all other things that we did with sine and cosine also applies, okay, in terms of the horizontal compression and expansion, in terms of the horizontal shift, and then vertical shift. Okay, so here is the graph. And let's write up the information. The period of the function tangent of theta was pi, and the coefficient that you see in here, that's what the b value is. So it's pi divided by that. That will give you the period of the function, which is pi. Okay, x-intercept 0, as you can see, very simple, 0, pi, and every pi interval it repeats. So 0 pi, 2 pi as well, and then keeps going 3 pi, and so forth and so on. Well, y-intercept is 0, and then asymptotes. Asymptotes are the ones that it's very important. So in this case, now when you use Desmos, they don't draw the asymptotes, but you need to, when you do a freestyle graph, you need to draw them. Okay, so that's how it is, and so that you can show, and then you have to come up with the equation of these. And the equation of these, you know, what you have is theta or x, right? In this case, my theta is the x-axis. So the equation of these, theta equals 3 pi over 2, and so forth and so on. And then this one is theta equal to pi over 2, and this one is theta equal to negative pi over 2, and depending on what interval they're asking you to do, that's what you have to write. Great. Now let's go ahead and look at the components of the total tangent function. I will not graph that in details the way I did with the sine and cosine, because it's a repeat. Basically everything is repeat. It's just that it does looks a little bit different, but you know what that is. So A is a vertical expansion compression. Make a note, there is no amplitude. We don't have amplitude, just the expansion, vertical expansion and compression. B is the horizontal expansion compression. Okay, and then C, the vertical shift, and the horizontal shift is C, and D is the vertical shift, depending on if it's positive or negative. Okay, so we're gonna do a quick graph on Desmos, and then that would be it. Okay, so this is the graph of tangent of x. We already had that. We don't need to have a coordinates on them. And then this is the graph that the equation that we're gonna graph, and notice that again, vertical expansion by a factor of 2. All these values on the graph they just double, and then there's a shift towards the positive pi over 6. Okay, so each of these intervals are 1, 2, 3, 4. There are pi over 8, but it moves to pi over 6, each one of them, and then everything goes up by 2 factors. Now notice that once you do the shift, the horizontal shift, that means your asymptotes also changes. So let's graph this now. So here it is, and notice that now your graph is changing, right? So it is a stretched, right? So it's not, the curvature is not as profound. It's kind of a subtle curvature right there, you see. And also what you can see is that the x value, the x-intercepts are changing. And as well, the most important part is that your the asymptotes are now changing. Okay, the asymptotes are now, they are shifted by pi over 6. That's the key point here. Every asymptote has been shifted. So pi over 2 has been shifted by pi over 2 plus pi over 6. With 6, it is 2 pi over 3 becomes the new vertical asymptote. Okay, so pi over 2 plus pi over 6 is 2 pi over 3. So notice that all the vertical asymptotes have been shifted by pi over 6 to the right, and then the last piece that we did was plus 2. That means all the points moved up. That's why the graph is now, the green graph is shifted up a little bit, and the curvature here at 0 0 that used to be that point there in the center, now it's 2 values. This is 2, that's 3, that's 4, that's 5. So now you're looking at 2, and that makes sense. Okay, so this is the equation. I wrote down all the specifics in here that you can see that we talked about, so that you know it. And then this is the graph. And then what I've done is that I included the asymptotes as well, because you don't see it on Desmos.